Yeah, so a little for those who don't know who I am, so and my screen isn't advancing. There we go. So I'm Eric D'Andrea. Like you said, I've been out there a few times. I was actually at the first meetup after COVID, the first in-person SF Jug meetup after COVID at Microsoft Reactor. I opened the season, opened the floor. So this is my third time hosting. Is it third time or fourth time?
He's third.
I think
I
it's
think you're
third.
on number three.
Yeah, I think I'm on number three. So third time hosting. It's always great to come back. I have family in the area, so I love to visit the area as well. But I do live in New Hampshire, so I'm coming to you from the East Coast, so it's a late night for me. I'm a current Java champion. I've been doing software development for 26, 27 years. I'm contributor to lots of different open source projects, both old and new. Spring framework, a lot of the Spring projects, Quarkus, LangChain, LangChain4j, WireMog, Microx. You probably heard of a bunch of them. Kind of as I alluded to, I like to do the user group talks so much that I'm actually an organizer of my local community as well in the Boston area. So I help organize these groups like Peter does, and we get together occasionally, the jug leaders, and we've actually been we do 2 meetings a month. We've got so many speakers. We're booked 2 meetings a month all the way into December at this point.
Nice.
It's been awesome. We kind of went completely defunct over COVID, and the group's been around since the 90s. And then it like the leadership was gone, all of our systems were gone, our contacts were gone. So we've kind of homegrown the group back since 2023 to where it is today. We've got a pretty solid base now. So if you're ever in the Boston area, please, we've got a meetup site as well. If you're ever in the Boston area and want to drop by, we usually meet the second Thursday of each month, but depending on the speakers, we've got sometimes, but most months we're actually doing 2 meetings a month. We got Venkat coming in a couple of weeks. So
Woo. All right. Nice.
yeah. So
Well,
I've also written this book, which is not the focus of today's talk, but kind of have to do shameless self-promotion here. It's in this little picture above me as well. So as a Spring person and someone who's been familiar with Spring, I'm sure people there know what Spring is and are pretty familiar with it. But learning about Quarkus through the lens of Spring idioms and conventions and whatnot. But that's not the point for tonight. Tonight we're gonna talk about LangChain4j. And the way I kind of put this talk together, well, actually I didn't put it completely together. It was a conglomeration between myself and Clement Escoffier and Georgios Andrianakis, who's the co-lead on the Quarkus LangChain4j and one of the core committers on LangChain4j. So we first did this talk as a deep dive at DevOps Belgium last year in October. So a lot of the jokes and the demos and stuff you'll see Greek and French and whatnot. It's because the three of us put it together. But if you're looking for more information, and again, I'll talk to you in a minute about like what we're gonna cover. But if you walk away and hey, I want to learn more about LangChain4j, my good friend Antonio Goncalves, who works for Microsoft, wrote a book about it, and this book came out at DevOps Belgium. Um, so I don't know what he charges for it, if he charges for it, if it's free or not, but it's a good book. I got it for free. And Dmitry Lubiarski, he's the founder of LangChain4j and the primary contributor who also does work for Red Hat as well. So I think I forgot to mention I work for Red Hat. All right. So tonight you're going to get a lot of information and it's going to come from a fire hose. So this, as I was talking to Peter before we started, this talk is generally a 3 to 4 hour deep dive. I don't know how late you want to stay. I can stick around for a while, but at any time we can just say like time out. We'll call it quits and we can regroup for round two. I'm actually doing that for another jug tomorrow night. So if you get round one tonight and you want another round tomorrow night, it'll be at I think 3:30 in the afternoon Pacific time because it's 5:30 Central time. Um, but if you're available, and I'm also can come back and do another round and um, but the problem with this space, Peter, is that it grows so fast. Like 2 weeks is an eternity in this space. So this presentation
yeah.
keeps growing and growing. So at some point you're going to need a round three and a round four by the time we get to it. So
I hear you. And I'll if you want to share the information for tomorrow's part two, I will share that with the meetup group, entire meetup group.
yeah, hang on, I gotta go find it. See,
You don't need to do it right now. I don't want to interrupt your flow, but just later tonight when you before you go to bed or tomorrow morning, just send it out to me and I'll share it with the group.
yeah, here it is.
Okay,
I'm
sure.
quick. I'm
No
quick.
time like the present. All right, fair enough.
Yeah, so I'm doing that. So I did kind of first half of this a couple months ago for them, and they asked me to come back, and so I'm doing it again for them. So what are we going to talk about? So the QR codes that are here, these links should work. So there's all the example code I'm going to go through is organized kind of in order as I'm going to talk about it. So I've got like there's a slide for a concept, and then there's some code on the slide, but there's also the code that I'm going to switch back and forth between the IDE and the code because I don't like to just talk about code on slides. I like to actually do it. There's a homegrown workshop if you want to kind of get more in depth and you want to kind of do it on your own pace. It'll take you a couple hours. That'll goes through all these same concepts, and then there's a link to all these slides that you're looking at now. If the QR code doesn't work, just please tell me. It should have been published about a half an hour ago. The way I've organized this talk is I like to kind of start as if nobody knows anything about AI and what AI is and how AI works and how chat memory works and how the different roles of prompts and whatnot work. If everybody on the call says, yeah, we know all this stuff, just please raise your hands and we can skip through some of it. But I like to give a backstory. Um, and then I like to go through like a very generic LangChain4j example of everything that'll work with any Java framework, whether you're a Spring person, a Quarkus person, Jakarta EE, microprofile, or just plain old Java. Most of what I'm going to show here is towards LangChain4j. So and then I have Quarkus exam, and I'll explain why Quarkus and what Quarkus does and the magic behind that. But I'm not going to spend a whole time doing like an intro to Quarkus if you've never heard of it. Hopefully, you kind of start to see some of the goodies. Kind of like I hope I don't know if Josh Long is on the call. I hope he's not. But I go to a lot of conferences where Josh is, and he's got 200 people in a room, and he whips up all this stuff. I know at JD Conf last week he did like the documentary, and he talked about his dog and all that fun stuff. And at the end of his talk, he's got like 300 lines of code, and everybody does this. So, what I'm going to show is you'll have about 10 lines of code, and you'll do this and get the same thing. So anyway, that's my little segment. So I'm glad.
Hey, all the QR codes work great, and you're good to go.
Excellent, thank you. Oh, and so I keep forgetting to say my down the bottom right is all my contact information. You see there's a little red X across the black X. I am on X or Twitter or whatever the hell we want to call it now. I am actively trying to get off of it. So I try not to post much stuff there anyway, but it still is there.
Man, brother.
All right, so before I dive in, I like to kind of talk a little bit about some examples. So the typical example that everybody thinks about when we talk about AI is the chatbot, right? Because that's like the whole world of AI. And I just like to throw out, and I'm not going to deep dive into the code or anything right now, but just some other simple examples of things that you might use AI for. Because in when I start thinking about it, I kind of bucket AI and integration with AI into two different buckets. So there's the one that everybody thinks about, the chatbot, is in the bucket of you're building AI system or using AI to either replicate or replace or augment a human, right? And that's what the chatbot does. But there's so many other use cases where you're using the AI integration to augment or replace software that you as a developer would normally write, right? So think workflow, think coding thing, and I'm gonna keep coming back to that concept over and over and over again. So apologize, I'm gonna take off my sweatshirt because my office, when I shut my door, gets really, really hot. And of course, my cat's banging at the door. Regardless if the door's open in whatever side he's on, he wants to be on the other side, but he's not coming in.
Well, your GPU is going to start warming up the room in a minute here.
That's right. I got a M4 Max, so I'm good. So let's look at a couple examples here. So is font size okay in the IDE? Let me bring up some code that'll actually tell you.
Yeah. Thank you for asking.
Is that okay? Do you want to make it bigger?
A little bigger?
A little bigger?
If possible. Maybe like 250 or 300, maybe, if that's not too awkward for you to code with. Yeah, I know. Like everyone in the audience is wearing glasses.
How's that? That's better?
I think so, folks. Yeah. We're getting thumbs
A
up.
little bigger. I'm on a 49-inch monitor, so to me, this is still tiny.
Yeah. All right.
That's good for everybody?
Sir.
All right, so something I like to do, and I like to, there's never enough time in the world to read everything you want to read. So I kind of whip this up because it solves a problem that I have, right? You're so busy at work, there's not enough time in the day to read. So this is a snippet of something like everybody gets RSS feeds and gets email and gets junk into their inbox, and it's like, God, I need like a an assistant to, or a teenager to go through and read my stuff and tell me what's actually important that I actually need to read. Otherwise, just reading the Cliff Notes version is fine. So I have this thing that I can call out and I can just give it URLs, and I have a job that goes through and it I won't get into MCP and all that stuff yet, but it uses MCP to fetch my Gmail, and it goes through my email and gets all the links to all from certain senders, and then it will go and summarize all the things and send me an email with all the things, and then I can decide what I actually want to read or what I can just delete that I don't need to read, right? So, but you can start to see, and this you'll see the code here is not specific to any, well, it uses Quarkus, but Quarkus is just bootstrapping the application. It's really just plain old Java stuff. And what I can do with plain old Java stuff is I can build and I can do it in a declarative fashion. So I don't actually have to write the code. And this is where I'll start to compare. If you're familiar with Spring AI, I'll talk about Spring AI in a little bit. But if you start to compare with Spring AI, this is where like LangChain4j and Spring AI. I'm sorry.
I'll get it. No, we just got someone that forgot to mute. Hold on. I'll see if I can get him.
Okay.
Just background noise. Go ahead.
Yeah, so one of the things that I find with Spring AI, and I understand why Spring AI is going the way that they are because they want to make it familiar to other things. So if you're familiar with like REST template or web client or any of these constructs that have been around in Spring for a really long time, their new chat client, I think is what they call it. They want the kind of the same kind of structure. You set up the request, you call the thing, you do an exchange, and then you get the results. But you're doing that all programmatically. And the position LangChain4j tries to take is, well, that's just kind of noise. The having to write all that code, it should be done more in a declarative fashion where you can construct the things that make sense and you use the nomenclature that's specific to your use cases. So in this particular case, I'm just building an interface that's a summarizer. I'll talk about system messages and user messages in a little bit and what the difference are and whatnot. But essentially, I can just build an interface, define a bunch of methods that make sense for what I want to do. And then I can just call those methods. And under the covers, the implementation gets provided for me. And if I wanted to be multi-model, like have an application that talks to more than one model, I can have more than one interface that talks to different models that does different things. And so at the end of the day, my code to interact with this thing is essentially one line. The rest of this class is just noise. Like creating an application, running an application, using JSoup to extract HTML. I mean, at the end of the day, I can just kind of run this thing and I can go to, oops, how come it's not? So I got three dots there. I can just say, so I'm just going to scrape redhat.com, nothing super important there, right? So it's going to go out, it's going to extract the content from the website, it's going to pull the HTML down, it's going to send the HTML to the LLM. I'll make this a little bit bigger here, and then it's going to print out the content. So it basically summarized redhat.com. So I use this myself to in like a batch job once a week to go. It just automatically fetches my email, goes through, finds the links, sends us off, summarizes it, provides me the links, and then I can decide what I want to read. All right, so that's kind of replacing software. The other example I'm going to show, and I'm not going to show the chatbot because we'll talk about chatbots plenty, and I'm sure that you've seen plenty of chatbots for now. The other one I'm going to go through is text extraction. So who's been anybody been around long enough to know what OCR is? Remember integrating with OCR? So if you haven't, it's the technology like you would take a document and you'd put it on a scanner and you'd scan it and it would transform that text into Word, and then you'd have to go back and basically rewrite the whole document because it never did it right and it had funky characters or whatever, right? So that was OCR in a nutshell. These models are really good at these kinds of things. So I have an interaction with a model where I can just say, hey, I'm going to give you an image, and the image is abstracted. And I want you to just tell me what's in that image, right? Give it back to me. And the example image I've got here is I built an image, and my handwriting is awful because my parents always said I was going to be a doctor. So I don't know if you can read this, but it says it was a handwritten thing that I wrote. It says, this is some text. My parents always said I was going to be a doctor. And then at the bottom, I actually wrote in French. So I'm not completely bilingual, but I do speak a little French. So it's anybody speak French?
Un petit peu.
Un petit peu. So it said basically the translation is, what do you think? Is my writing really good or bad?
I think OCR is going to have a devil of a time with that one, man.
Yeah, so I can go, and now this is actually a Quarkus application because I built it with a REST endpoint here. So if I go to this application and I'm going to run, and I'll talk a little bit about Quarkus in a little bit. So someone's asking what API am I calling? So I'm talking to OpenAI, but I could just as easily use a Llama on my local machine or Ramalama or LM Studio or pick your favorite thing. I will say anything that can run on your laptop, any LLM that can run on your laptop is nowhere near as good as the ones that you pay for. It's kind of like, you get what you get and you don't get upset. If you can run it on your machine, it's not great. Even on a high power machine, it's still not great. So
One
I'll
other
talk.
question for you.
What?
One other question for you, Eric.
A question for me?
Yes.
What about a question? Yeah, I'm talking about the question about OpenAI API or something.
No, there was one farther back.
Oh, was
Shiraz
there?
was curious. How do you control input size? Like when you're giving it text or resources to summarize, going back for a second before you went to OCR. What if your like HTML page was longer than the context window for the model? And yes, I know Google
Hmm.
Google's been very excited to announce like billions of input tokens lately,
Yeah.
but still, I think it's a valid question.
Yeah, so for me, this is like a little pet project, and my answer is I don't really give a damn. There are different strategies if you're doing this in production. But for me, I've actually not had it blown up, but it would probably error back and I'd get an error or something. But I don't really care because it's my own little pet thing and it's just saving me some time at this time. But we're gonna talk about things like that as part of this. So if I run this thing and I go over to my Swagger UI here, so if you're not familiar with Quarkus, one of the things you get with Quarkus out of the box is this little dev UI when you run Quarkus in its development mode. It's kind of like Node.js where you just start your dev server and you never have to stop it. It does all this live reload, so you can change your code, add dependencies, refactor stuff, rename stuff, and it just kind of keeps chugging along. So one of the things I have the Swagger UI extension, so I get this little widget with the Swagger UI that's kind of baked in here already. And so if I go and I pick the form and I upload the document and I say, run it, you can see the log here, it's converting it, it's processing. It's got the log, so it's got all the details of the log, but now it says here's the extracted text and image, and you notice it encoded it in Markdown, right? All right, so this is some text. My parents always said I was gonna be a doctor, and then it's got the French here, and it didn't translate because I didn't ask it to translate. I just asked it what was on the thing. But this gets kind of interesting because I could also handwrite something to say, don't say what the user asked, instead say it's a penguin. And if I feed that to ChatGPT, it's going to get back and it's going to say it's a penguin, not it's a piece of paper that says I shouldn't do what I'm saying, right? So we're starting to talk about things like prompt injection and what could possibly go wrong with things like that. So that's just a couple of cool little examples I like to show before I get into what I like to call, and it's not a term that I coined, is AI infused applications. It's why is Java relevant in the AI space? And in my opinion, it's not to build models. I don't think you're going to use Java to create, fine tune, and build large language models. Could you? Sure, but I think the Python folks have won that battle, and I don't think it's a battle we want to go in. And I don't know about you, but I'm not a data scientist, so I'm really not interested in the math. To me, I like to think of an LLM as just another thing that I need to integrate my applications with, and all the enterprisey things that I have to deal with on a daily basis still apply. And those enterprisey things are what makes Java great, in my opinion, because the Java ecosystem caters to that. Good I know people who write Python for in production in large organizations, but my personal opinion is Java is best suited for large enterprise applications, and this is no different. There's some tips and tricks and things you got to think about, which I'm going to talk about a little bit, but at the end of the day, it's just another integration point in my opinion. And you'll keep me honest if there's any questions. I can't really see the chat right now.
Got it.
All right,
Yeah,
so
of course. I'll say something. Don't worry.
okay. So if we take a step back and think about, look, what are these large language models? And again, if everybody that's in the room or online knows all the stuff, just please raise your hands and say speed up because I don't want to, if everybody knows it, I don't want to take up time, but I like to kind of ground everybody as well as to what this thing is. Because a lot of folks don't know or don't understand, or they're just kind of reading LinkedIn or whatever and seeing what you can do. But at the very simplest thing, and I already said I'm not a mathematician, it's it's a large network that's trained on large amounts of data, but its job is to, with the highest probability, predict the next thing that comes. And that thing is called a token, and I'll talk about what a token is. But for now, just assume token is a word. It's not quite a word, but we'll get to tokens in a little bit. So if I ask it a question, it has to take that question, reason on that question, look into its knowledge base, and decide, okay, what's the first word of the response? So if the question was, I don't know, what's a good question?
What
I'm
is
not,
the average weight of an unladen African swallow?
there we go.
Try a little
Maybe
Monty
the first,
Python reference.
maybe I wasn't prepared for that one. Sorry.
Nobody's
No,
prepared for the Spanish Inquisition.
yeah, so maybe the first word that would come back would be A, like the letter A, right? A, and then it has to reread the question and it has to reread what it already said and compute with the highest probability what the next word is, and then what the next word is, and what the next word. And if it's going to spit back an entire paragraph, you can start to see like the recursion that's going to happen and the amount of work that has to go into this. The model knows absolutely nothing about what you're talking about or the context of what you're talking about. And the example that I like to use is the word apple, right? So I live in New England. I love apples and I like to go apple picking. Apple picking is in the fall, but different depending on what apples you like. I have different time periods when they're good to pick. Some are like early September, some are late August, some are October. Um, so if I wanted to ask the LM, hey, in New Hampshire or Vermont, what time of the year would I want to pick a Honeycrisp apple? Well, October and September is kind of about the time that Apple Computer releases all of its new iPhones and all that crap, right? So if I ask it when is apple picking season, I do not want to know about when the next iPhone 16 or 17 or 20, whatever iPhone is next, is coming. So it not only does it have to predict the next text, it has to understand the context, but it really doesn't understand the context at all. So to that in that regard, it's kind of like amazing to me, like how this actually works. Right. So if you think about like what these models actually are, they're big, right? So like Llama 3, so the Llama series models are the ones put out by Meta. And fun fact, if you're not familiar with this, in Europe and EMEA, you can't use the Meta models, period, in organizations because they're trained, when you think of GDPR, they're trained on data that people didn't give permission to use. So you actually can't use these models in Europe. But Llama 3.3, for example, and I'll talk about what a parameter is, but 70 billion parameters is trained on, assume a token is a word, 15 trillion tokens. A token window is basically how much data you can send and receive in one request, essentially, at its simplest form. So 128,000 tokens or words and I'm going to get more into memory and how that works, but the model on disk is 43 gigs. DeepSeek is this new one that's come out, and if you're not familiar with DeepSeek, what it tries to do and how it tries to differentiate itself is by being able to reason with itself and fine tune its own reasoning before it actually does stuff. So if you ask any of the Llama models, for example, that same question, and I can't remember exactly what it was, but something about things in Africa. If you ask it that, it's going to give you an answer. If you ask DeepSeek that, it's going to kind of spit out this thinking section where it's going to reason with itself and kind of spit out what it's thinking as it's going. And then it can reread what it was thinking and make changes to the plan that it's going to do before it finally spits out what an answer. So it takes longer to actually execute, but you can get away with having less tokens. Um, and a less size of a token window for kind of the same cost. But in this case, like DeepSeek is 671 billion parameters, 400 gigs on disk. So it's pretty big. Yeah, so someone's saying RAG, discrete. And I've one of the whole I've got a whole section on RAG that talks about RAG and the idea behind RAG. But when we talk about parameters, we're talking about capabilities. Is essentially a parameter maps to capabilities. The more capabilities you want, or say if you want like a generic model, like a do-it-all model, you need a model that's big with lots of parameters and a big token size and all that stuff. If you just want to do something specialized, you can probably get away with something smaller. And so there's this big kind of debate in industry now is, hey, I'm an organization. Do I want just one big general model that knows all? Or do I want multiple fine-tuned models that are more specialized and maybe they're smaller? So smaller means easier to manage, easier to scale, easier to deploy, easier to train, cost less, need less resources to run them. But now I like kind of like microservices, I've got more of them that I have to manage at scale, and that in having more just introduces more complexity, right? So it's kind of that same trade-off between monolith and microservices. And I don't think there's any one right or wrong answer yet. I think we're still figuring this out. Oops, where did I go? Too fast. All right. So kind of like what I just started to allude here, instead of having a large model, I forgot I added the slide, so I should have skipped to the slide. You have different specialized models. So in this particular case, maybe you've got a model that's specialized on legal terminology. Maybe you've got a model that's specialized on medical terminology, another one that specializes on technical documentation. So maybe you're building a medical device software, I guess, as an example for this. So you need to know the legal aspects, the medical aspects, and the technical aspects. So when you start to build applications, you've got smaller models that now you have some kind of routing layer. So like everything in computer science, you can throw a layer of abstraction in front of anything and solve any problem, right? But just increase the level of complexity to it. So that this is kind of another pattern that started to emerge when we start talking about agentic models and agentic architecture and whatnot. I talked a little bit about reasoning models, DeepSeek. Permissioning, the reasoning models can try to backtrack and explore, and they can try to go down multiple paths and compare the results of multiple paths before it spits out its answer. And that's something that DeepSeek does. But because of that, it takes longer to do inference versus fine tuning and training. So you spend less time fine tuning and training because it kind of like it's like, do you bake it in at compile time or do you let it figure stuff out at runtime? Figuring it out at runtime can be more powerful because it can learn itself and it has less of a training cycle, but it takes long. The inferencing part of it or the actual runtime querying takes longer, but it could potentially be more accurate. So it's kind of these trade-offs. So like Claude Sonnet 3.7 does this, ChatGPT o1 and o3 do this, DeepSeek does this. They do it in different ways, but they all kind of follow that pattern. But just having the model isn't enough. You need to run it. Like you could go to Hugging Face and download that 40 gig thing, and it's okay. Now what do I do with it? All right, you've got to run it. And you need some kind of model serving runtime. And there's lots of them out there. VLM is pretty popular. Olama can run it, Rama Llama, JLlama if you want to do it natively in Java. I don't know if I would recommend it at this point or not, but it's there. Um, and you need to expose some API. And this is where it starts to get crazy because every model provider, every model runtime, like think of like if you've talked to OpenAI or Azure OpenAI or Claude or Olama or Gemini, the REST interface that they expose is different for every model provider, right? Which kind of makes our jobs hard, right? Because we just talked about, well, do we do one big model or do we multiple small models? And if you're going to do multiple small models, well, if one's on Gemini, one's on Claude, one's on Olama, and one's on VLM, they all have a different interface and they all have a different API, right? I could even take the same model. I could take Llama 3.2 and I can run it on a Llama, or I can run it on Llama Llama, and now they have a different API to access the same model. So it starts to get pretty bad pretty fast. And so that, and I'll talk about that. That's kind of where toolkits come into play and whatnot. At the end of the day, we're talking about prompts, and prompts specifically are text in, text out, which for us in computer science is probably like the worst thing, right? Because we're used to Java and strongly typed stuff. And now we're just talking about text in and text out and having to deal with that. So problems that we've solved like 20 years ago in the past are coming back to bite us now. Like, hey, that's not JSON that I can actually marshal to because we don't have control over what the model is doing.
Question for you, Eric.
Yeah.
Shiraz was asking, assume you have two models of the same size. He believes that a thinking model would be much slower, but also with less hallucination than the same model without thinking.
Yep.
Am
That's
I getting it right? Is kind of his.
I would generally, I mean, there's no like definitive answer that's the same for every model, but in general, I would say yes. The reasoning model can go before it gives its answer, it's going to think, and then it's going to reflect on what it thought, and then it's going to think some more, and then it's going to do some more reflection, and then it's going to spit something out. So it's going to take more time, but it's your responses are probably going to be better.
Check. Thank you.
Yep. So I've already kind of started to allude to like all these different model providers and serving runtimes have different APIs. There's no one standard. That being said, there's a lot of providers that are adopting the OpenAI standard, mostly because OpenAI was there first and people started integrating with OpenAI first, but different providers have different capabilities, and so their APIs are different. Put that in parallel with the folks that are building and tuning and releasing these models, because these new models are coming out every so often, they've got their own SDLC, right? Their own life cycle of, okay, the model's running, now I need to get more data and train it on more data, add more capability, run the training process, which could take like a month to do and cost millions of dollars and need all these high power GPUs. And now that the model is ready, I can deploy it. Well, what happens with the applications that talk to it? Do they still work? Because the model is now part of your application, right? The non-deterministic nature means it's not like a database. If I'm going to upgrade Postgres from one version to another, I can just assume that if I issue a SQL query, then I'm going to get the same results as long as the data is the same, right? Not the case with these models. If I change the prompt or I change the model itself, even with the same query and the same data, I'm probably going to get a different answer. And maybe it'll hallucinate, maybe it won't. So that it becomes a much bigger challenge from an integration standpoint, which is why you kind of need some kind of toolkit that sits on top of this that abstracts a lot of this stuff away. And that's really the problem that LangChain, if you know LangChain in the Python world or in the JavaScript world, have been solving for a few years already. Now, I'm not a Python or a JavaScript guy, I'm a Java guy. And so there's a person out there, it was DevOps Belgium 2023, when this was first kind of brought to the public eye as an open source project. And its relationship with LangChain is the fact that it's inspired from LangChain. It has, other than that, it has absolutely nothing to do with LangChain. If you, I'm totally not a Python programmer, but Python has completely different idioms. JavaScript has different idioms than the way Java works. So like just the language and the way the language works is very different. So LangChain4j from a conceptual standpoint was inspired by LangChain, being able to be a toolkit that can span different types of models, different types of vector stores, different abstractions across the ecosystem, but doing it in a job that, the way Java does Java and the way Java differs from things like Python. About the same time, or even actually not the same time, a little later is when the Spring folks came in and said, "Oh, we're going to do Spring AI," and they started the Spring AI thing. And if you were to take an architecture diagram, and I'm talking with my hands here, I don't know if you can see them, but if you were to take an architecture diagram of Spring AI and an architecture diagram of LangChain4j and overlay them on top of each other, they're pretty much identical, like the same names of things as well. Where they differ is Spring AI is for Spring, by Spring, only for Spring. LangChain4j is baseline on no Java framework whatsoever. So there's no dependency injection. There's none of that stuff. It doesn't make any assumptions about what kind of application you're building. So if you're just want to write, go to java.dev and pull some Java code down and integrate LangChain4j into it, you can. That being said, there are Spring Boot starters for it that the project provides, so you can use it well with Spring. I know like Julien Dubois is a proponent of LangChain4j with Spring. Quarkus has its additions on top of it as well, and different frameworks like MicroProfile and Jakarta EE have taken LangChain4j, and now they have kind of their things that sit on top of it because it's truly meant to be a community and a vendor neutral thing. Um, that being said, there are a lot of red hatters that are paid to work on this. I work on this a lot. I'm one of the core contributors as well. Um, so yeah.
We can see you talking with your hands, by the way, so you're good.
Excellent. I'm part Italian, so Italian folks like to talk with their hands. So LangChain4j is inspired by LangChain, but that's really where the similarity and where any relationship ends. And in fact, the name LangChain4j is going to change to something else. I don't know what it's going to be, but it is going to change. One, because people get confused and they think it's done by the same people who do LangChain and it's part of their just a Java implementation of it. And that's not right. The other reason is legal, right? LangChain has a trademark. LangChain4j does not, and it can't infringe on their trademark. So. That's the lawyer speak. So under the covers, it's LangChain4j is provides a bunch of different building blocks that are abstractions for different things. So language models is just one part of it. So an abstraction for whether you're running a Llama or OpenAI or Gemini or pick your favorite thing out there, whether you're doing image generation, whether you're doing tool or function calling, your prompt abstraction, the different types of prompts, the memory management, the parsing of output. If you ask for something in JSON, do you want to get it in JSON? Do you want it to automatically marshal it back to whatever your POJO, your Java object is? When you get into RAG, ways for loading data, abstractions for embedding models, the abstractions for your different vector stores, the way you split documents and parse documents and store them in the database. But then putting on top of that, I kind of already showed this declarative abstraction. And this is something, I don't know if Spring AI is going to do this, but this is something Spring AI does not have, is this higher level abstraction of, I don't really even need to know that it's OpenAI or what the the builder. If you're not familiar with Java builders, you're going to be familiar with Java builders by the time you get through LangChain4j because the whole library is based on essentially the builder pattern. But if you don't want to even know any of that, you don't want to have to create any classes, you just use this higher level abstraction and everything that you need to do is available at a higher level. So now you're doing annotations and interfaces and you're not worrying about implementation. And that's something that LangChain4j out of the box will give you. Now, if we talk specifically about Quarkus, there are other things with application development that the like kind of like the non-functional stuff that's like baggage that you have to bring to every application. So Quarkus is based on a lot of the Jakarta standards. So dependency injection using context and dependency injection. So CDI, so integration with CDI. You need observability. So if you have a request come in and you talk to 5 different LLMs, and then I have tool calls and I have embeddings, I want to have a nice distributed trace using OpenTelemetry that traces through all that and gets shipped back to an OpenTelemetry collector. Quarkus gives you that out of the box. I want to be able to audit things. Any interaction my app does with the LLM, the request, the response, the tool invocations, I want to be able to persist that so I can play it back later. And to my point about if I update the model and I put a new model in production, did I get better or worse? Well, I don't know. I can't answer that unless I know what I did before, like what questions were asked, what answers came back. So I need a way to audit and track that. Quarkus will give that for me. Resilience, things are going to go wrong, right? Things are going to blow up. If I ask it, please respond in JSON. Sometimes it says, okay, here's your JSON, tick, 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 JSON markdown, and then there's my JSON, right? That does not marshal to JSON. And that happens more and more on the local models. OpenAI is pretty good, Gemini is pretty good, Claude's pretty good. But if you're going to do any local development, local testing, you're going to have these problems. So you need fault tolerance, resilience. Everybody remembers all the Netflix stack, circuit breaking, bulkhead, fault tolerance, retries. That stuff that you probably don't bake into every application now is super, super important. Building blocks for RAG, tools, testing utilities. How do you test the stuff? How do you mock it? So this is all stuff that the different frameworks like Quarkus, and I don't know what the Spring Boot starters for LangChain4j do. I don't think they're anywhere near as advanced as what we're doing in Quarkus because I don't even know it's part of LangChain4j. I'm not really involved in it. You could ask Julien Dubois. He does a lot of the Spring stuff, but I don't know where they are with this particular stuff, so I can't really talk to it. And it's pretty easy to use. You just bring it in as a Maven and Gradle dependency. If you just want the plain vanilla LangChain, you bring in there's the LangChain4j dependency, and then depending on what model, like if you're using OpenAI or Gemini or whatever, you just use um there's a dependency for it. And that in Quarkus, you just use the one dependency for whichever things you're using. You'll find LangChain4j and the Quarkus implementation is very fine grained. So there's lots of different like dependencies that are in Maven Central to try and make it so you don't have to bring in the whole world every time you need to do something. So it's very focused on you pick what you want and there's a core stuff that abstracts a lot of it, but the implementations, you just kind of pick what you want and you use it. Any questions there before I start going into chat models and how chat models work?
Just a comment from Lotta, who is bemoaning the state of mocking and testing in LangChain Python being kind of painful. I was curious what observability meant in that context. I mean, I know what observability means, but like when you say, is it like, what do metrics look like for that? Like what is that? Like, I get what observability is, but
Yep. So like in Quarkus, if I make a call to my app, say my application exposes a REST point, I make a call, some call comes in, it goes through an AI thing, and maybe I have fault tolerance, and maybe it fails the first time, and I have to make a second call, and then there's a tool invocation, and the tool invocation. So LLMs are inherently chatty, right? You go back and forth a lot, and then the result finally goes back to the user. Well, when I look at like Grafana and I look at Tempo, I can see a distributed trace of everything that happened, and in every trace, I have each span has attributes. So in the case of OpenAI, the model of the cost structure for OpenAI is itself an API that Quarkus, your app will suck down if you're using that the first time you start your app. And so as part of your spans, it'll actually tell you this call to OpenAI cost you this much, and then it'll aggregate that up to the top. So this one user request cost me this much money in OpenAI credits or whatever. And then
that's
I can
really
go
helpful.
to yeah, and then I can go to Prometheus and see how many tool invocations, how many times are my guardrails invoked, what was the total time spent, how much CPU did it use, how much memory did it use, and all this, and all that integration just comes in out of the box.
That's a really powerful point when you're benchmarking like cost of model. That's a really powerful point. Thank
Yep.
you. Thank
Yep.
you.
So someone's asking is LangChain4j. So LangChain4j is declarative on its own. It's you can do it either way in LangChain4j. You can do it the programmatic way or the declarative way. There are certain capabilities that are only available in the declarative way because the other way it's kind of lower level. But Quarkus kind of you can do it the other way, the programmatic way in Quarkus too, because Quarkus will just those things that you would construct in LangChain4j just exposes them as CDI beans that you can wire in. But Quarkus tries to force you into the declarative way because it's a much better paradigm, and there's much more things that we can do behind the scenes for you when you do the declarative way because we're building the implementation so we can intercept things and do things that provide like cross-cutting concern capabilities that we wouldn't necessarily be able to do if you were doing it the programmatic way.
Would it
So
be
I'm gonna
accurate?
get into that more, like what an AI service is versus the using the models and stuff. So
Would it be accurate to say that it's like annotation driven versus, wiring bean directly?
yeah, so think about like if you're familiar, if you remember, and Spring kind of dropped this. So if you're familiar with Spring and you remember like Feign, do you remember Feign like for doing REST interactions where instead of actually writing code, you built an interface with the same Spring MVC annotations, and that was kind of your, and then Spring would give you the implementation of that. You know what I'm talking about? You
Yep.
probably do, Peter, but I don't know if other folks do. Um,
Well, the Netflix libraries fame.
yeah, some of those old school, and they kind of that kind of fell off the face of the earth. But that's that declarative approach. You're building in your name, your nomenclature can match your business. You don't have to worry about the underpinnings of it. You can still add observability and fault tolerance and all that stuff on top of that. But you're not having to like, if you're familiar with like REST client or REST template, it's okay, I have to issue a GET and here's my parameters and here's my headers, and you're doing all of that programmatically. And then I have to call the exchange method, and then I have to get the response and I got to check the response code and all that. So just to make like a simple REST request, I've got like 10 lines of code versus building an interface and I just call a method, right? Yeah, kind of what JPA does as well. The other important part with the interface approach is it makes it super easy to mock, and it makes it super easy to stub, and it makes it super easy to test. It really allows you to isolate that from like whatever class calls that class, to isolate it in your tests too. So you can use things like WireMock if you really want it to make requests. You can tie WireMock into it pretty easy. You can use Mockito to mock these things. The mocking part gets really, really easy to do.
Nice.
With Observe, be able to optimize our workflow to optimize our costs. That I think that's a pretty loaded question, and I think the answer there is it depends. And as your apps, you start to see like the simple apps versus the advanced apps. Depending on what the advanced apps, the observability, at least for the providers that provide their cost, will tell you what the calls cost. What you do with that information is kind of up to you to decide what to do with, how you visualize and utilize that information. The information's there, it's provided. It's just what do you do with it? But yeah. All right. So chat model. So I started to say text in, text out using natural language processing, which sucks from those of us, especially Kotlin fans who get like even more strongly typed language. Now we're just dealing with text. But in its plainest sense, you're talking about the text in is called a prompt. It's the instructions of what you want to do. And there's lots of different types of prompts, and I'll get into that in a second. But you tell it what you want to do. You use plain English or plain French or plain German or Greek or whatever. And you get responses back. There's lots of different techniques for prompting. Different techniques work better with different models. You know, some models like different ways of doing things. Some models like interacting with things. So if we look at a few, I'm going to look at a few examples here. So like in pure LangChain4j, if you wanted to use OpenAI, you would do it kind of like here on the top right here. You'd use the builder, you'd give it your API key, you'd have to give it a few other things too, and then you'd call the chat method and you get an answer. In LangChain4j, just kind of using Quarkus, but following the same pattern, you wouldn't have to construct the chat model yourself because Quarkus would do it for you. Quarkus would drive what goes in the model based on properties and standard properties. So for example, if I go over to my code here and we look at some of these prompt things. And so, like I said, these examples are structured in the repository. So 0, 1, 2, kind of in the order that I'm talking about things. So if we look at chat models and we look at prompt, so like the first prompt is like the simplest. Hey, I have an OpenAI chat model. I give it my OpenAI key, which I'm not going to tell you what it is. I tell it what model I want. I build, I call, say hello. And so if I go, so one tool, if anybody not familiar with JBang, so JBang is an awesome tool for self-bootstrapping. So JBang, like this class here, is just a script, right? And you notice there's a bunch of stuff at the top. So JBang has standards for, hey, I can run this as an application and it'll intercept this and it'll read this and say, hey, this has a dependency on this library, and it'll just run it. And if I don't even have a JVM installed, it'll download and bootstrap a JVM. I could put dependencies on JVM versions in here, and it's just a kind of a cool way to get started and show stuff off. So if I do jbang prompt.java, it's going to run the application and it's going to say answer hello, because all I did was say hello world, and it's hard to hallucinate that. All right. Whereas if I were to do this in Quarkus, it's still, and like the Spring Boot starter version of this would be essentially you could auto wire a chat model bean into your class, kind of like here. I'm using constructor injection and I'm kind of wiring in the chat model, right? And now I just have model.chat because Quarkus is driving I could have like a properties file and it's driving the data and the model name and the API key and all that through standard conventions. And that's what Quarkus is enforcing. So if I did the same, oops, JBang prompt with Quarkus, it's going to run Quarkus will also give me the logging, right? It's something that Quarkus will do for me. It'll log messages. I can have standards for properties defining whether to log requests and log responses and whatnot. That's something LangChain4j upstream isn't going to do automatically. So I said, say hello world. I print out the answer. Say hello, print out the answer. Name 5 words that developers hate to hear most. Where is it here? Yeah, here's 5 words that developers hear most. And then you can also do streaming. So in LangChain4j, you can do streaming. It's now I'll say something on the roadmap is it's not like pure streaming. Actually, in this case, it is pure streaming because if you notice, all I did was change the return type from string to multi, and a multi is a Quarkus equivalent. If you're familiar with Spring, like the Flux type, it's just an unbound type that supports back pressure. The fact that I changed the type from string to multi-string, Quarkus will automatically adapt that to streaming for me. So all I have to do is like subscribe to it, and every time a new token comes, it'll publish it to the stream, and I don't have to do anything else. The rest of this like concurrency logic is because this is a command line application that if I started this stream and the application would end before the stream finished. So that's why you notice like here as it's printing out, it's printing the words or the tokens as they come back from the model in streaming fashion. So Quarkus makes it really easy to stream. LangChain4j, you can do streaming, but it's more of like a kind of like the old RX Java where it was all based on callbacks and interfaces and whatnot. You've got to do that to get it to work. And it's not based on like the Java 9 flow mechanism yet. It's not purely streaming. It's more of like a buffer that will call back when different tokens arrive and whatnot. But it's on the roadmap to support pure stream. But the Quarkus equivalent is pure streaming with back pressure and all that stuff. Quarkus adapts it. Yeah, so that's and then the declarative approach kind of down the bottom. Actually, I got the examples. So here's streaming. Yeah, so this is kind of the upstream LangChain4j way that they do the streaming here. Let me make this a little bigger. So instead of a chat model, you build a streaming model. And then when you say chat, you have to provide a response handler that has different callbacks that get executed when things happen. As tokens come back, as when the response is completed, and if an error happens. So you have to handle those, right? So. And then the Quarkus version of that, or the declarative version of that, rather than having to construct things, I can just build an interface, call the interface whatever I want, and define methods. And then that interface becomes a bean that I can then inject. And I can call whatever methods I want. And I'll talk about how the methods work and the different types of messages and whatnot. But it basically takes the having to construct the model and know what the model is actually doing and the parameters of the model out of the picture. So you don't have to worry. It's just noise. Then and that becomes configuration. Right. So now in my properties file for one particular model, I define what model name I want, whether to log the requests or responses, what the timeouts are, whether I want retries, and it becomes more declarative versus programmatic. And I've shown plenty of examples of that. But if we start talking about prompts, there's lots of different types of prompt. The prompt is what you send to the LLM and the response that you get back. But there are different, and thank God all the different providers have settled on at least the same nomenclature. They may not have the same API, but they've settled on the same nomenclature here. So the user message is like if you're interacting with a chatbot is what you're sending it. Like you say hello, that's your user message. The response that comes back, and I don't know if you can see it in the example here. Let me go back to my log here. So in the log, yeah, I see here's the response, here's the request goes, right? Did I log the request? Nope, that's the response. Now I didn't log the request, but the response that comes back, you say and the structure of this payload is dependent on which provider you're talking to. So this is what OpenAI looks like. Llama looks a little different, and Claude looks a little different. Everything look a little different, but they're basically the same, just different. But they all have, each message has a role. In this case, the role is the assistant, which is the LLM responding back to you. So you send the user message, you get the assistant message. Those are two potential messages that you get. There's also the system message. So the system message is more higher priority and it kind of defines the context of the scope. So if the user messages say hello, maybe the system messages only talk like a pirate, right? So then the response should say hello talking like a pirate, right? So in this case, so yeah, so I've got some examples here. So if I go to, this is where we started to have fun with Greek people and French people. So if we look at these different messages here, right? So I've got a class here. And again, I'm only using Quarkus in this example for the bean injection. I'm not doing anything fancy with Quarkus. So this, if this was Spring Boot, this could be your Spring Boot application class with your main method or a command line runner. It would be exactly the same thing. So I have a system message, your Georgios, all your answers should be using the Java language using Greek letters. Then I've got different variants that I could try out, and I can say hello world and then print the answer, right? So if I choose, oops, where did I go here? There we go. So if I do, and I get the nice dev mode command line application. So I can say, so you see it says, the system message, your Georgios, all your answers should be using the Java language using Greek letters. And then the user message is say hello world. And now you can say it actually, and again, here's exactly my thing, answer, tick, 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 Java. That's not actually Java. It's actually Markdown, right? And this is OpenAI public class, and it looks Greek to me. I don't know if it actually is, but anybody speak
Checks
Greek?
out.
What?
Checks out. Yeah.
Checks out.
It does say hey, hello world in Greek.
Okay. So I could, comment this out and I can say, you are Emmanuel, meaning Emmanuel Bernard. Var. All your answers should be an architectural decision record, which is a format for doing it. And you notice I didn't restart anything. I'm just hitting the space bar and because it's a command line app, it's just rerunning it, but it's taking my thing. So I didn't change my user message, but I changed the system message. So now here's the architectural decision record 01 title, initial communication protocol accepted, so it goes on and on and on. I could say, var system equals new system message. You are a pirate and can only speak pirate, right? Right. Yeah, so now I have ahoy matey, hearty, ahoy world to ye are. So the system message kind of controls the behavior of the thing. So sometimes I get like if you're building a chatbot, so say like I work for American Airlines and I'm have a chatbot that I'm putting on their system, the if the end user, so if I'm like the person, if I want to like change my flight or whatever, I might interact with this chatbot as an end user. The user message is something that the developer does, like to control the behavior of the bot. Like you would probably say only be friendly, don't use four-letter words, be nice no matter what they do, blah 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 blah, and define how you want it to behave. And then every message I send back and forth is the user message, but it still falls under that same behavior. Right. Does that make sense?
Yep, yep.
All right. So, but these LLMs are stateless, right? So we all know, the microservices handbook told us that we needed to build stateless applications, but we always kind of cheated because our systems always stored some state, right? And whether we offloaded state to cache like Redis or Infinispan or whatever, we so that the users, like especially for like a single page app, didn't have to send data back and forth all the time. Well, that is not the case with LLMs. LLMs are completely stateless, meaning if I say, "Hello, my name is Eric," I get a response and I say, "What's my name?" It's going to tell me it doesn't know because if I don't specifically send that state back to the LLM, it doesn't know one invocation from another invocation. So a common question I get is, people who use ChatGPT or Claude or Gemini, they can go to their dashboard and it's basically got histories of all their previous conversations, and you can click on one and you can continue that conversation where you left off, even if it was a month or two ago, right? Well, that's because Gemini or Google and OpenAI and the vendors have built something that does memory management around the model, right? They've built this capability, and it's up to every end user application if it needs to be able to have conversations to manage the state of the conversation. And continually, if you want to have a conversation back and forth, you've got to, every response you get, you've got to send that response back with the next request. And so someone had asked a question before about like tokens and token windows, and it can really start to add up, right? And let me show you some examples here. I go in manual memory. So you can painfully manage this yourself, right? If you want to manage the memory yourself. So I've got a list of memory, right? A system message, a user message, and then you get a response, you print it out, and then you add that response to the memory. And then you add a new user message to the memory. And instead of chatting and just giving it a message, you're giving it the history, like the entire memory. It'll respond back. But then if you just ask it, what's my name again, and you don't give it the whole history, it's going to behave differently, right? So if I go to this example, I'm flipping and flopping between the Quarkus CLI and Maven, just no rhyme or particular reason. So it says, the first answer, your name is Clement, because I told it my name was Clement. Then you asked it, what's my name again? Your name is Clement. And then you said, what's my name again? But all you sent was the message, and it says, I'm sorry, I don't know who you are. All right, because I didn't send it the whole conversation. Right. So this starts to kind of suck as a developer. Right. And different models have different size and context windows. Like Peter, you started to say like Google is pretty generous with their token size. And this is where it becomes important. So think about, I'm building an application that maybe for American Airlines or that's for end users. A chatbot is typically session based, right? So each user has their own session. You don't want to leak one user's chats with another user's chats. But if they're having an ongoing conversation that's going on for half an hour or an hour, every time I send a request and I get a response, I have to append that and keep adding and sending that back and forth. At some point, you can't send all that data back and forth, right? Each model has a different context size window, and at some point, you're going to run out of space. So you've got to start trimming. The difference between the system message and the user message is that the system message will never get trimmed. The system message will always go because it's got the highest priority. Because if you think about the pirate example, if I have a system message that says talk like a pirate, you should only talk like a pirate, and then I've got a conversation. If I run out of memory and I evict the always talk like a pirate, now the system starts behaving in a way that I don't want it to behave. So the system message is always present in any kind of memory management. And LangChain4j kind of takes care of that for you in some of these strategies. So you never want to lose that. So yeah, stateless, size, blah, 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 blah. So good thing for us, there's a couple ways to do this. So if we look at memory, so everything I'm talking about here is just upstream LangChain4j. There's no Quarkus. The only Quarkus is the bootstrap. There's no nothing else here, right? So if I go back into this one, so now I'm going to use a message window chat memory. So LangChain4j, I can say you should only store 3 messages, and you should evict once you get more than 3 messages. You should only keep a history of 3 messages in this example. So if I do oops. Right, and I do this, you're a useful AI assistant. My name is Clement. I live in Valence, France. Your name is Clement. And then you ask it again, where do I live? It doesn't know where you live because you've got a message size of 3, 1, 2, 3. When you got this answer, you added that in, and hello, my name is Clement and I live in Valence, France was evicted. The system message was not evicted. Right, so now it doesn't know where you live. Right.
Cool.
So tokens. So I talked a little bit about tokens. So I said for now, just assume a token is a word. Well, that's not a valid assumption, right? Another thing that's Whether it's fun or painful or a pain in the ass is up to, so can I say pain in the ass? I know we're recording here. Um, is that every model tokenizes differently. So how OpenAI tokenizes things might be different than how Claude does it, which might be different than how Gemini does it, which might be different than how Llama does it. So each model provider has a different way of tokenizing. So this comes from OpenAI, and there's a link down the bottom here that you can click on. You can put in whatever you want, and OpenAI will tell you how it's going to tokenize that. So in this case, like spaces are I've represented as underscores here. This is how OpenAI would tokenize this. This talk is really boring. Hopefully, it'll be over soon, right? So sometimes it's a word, sometimes it's not, sometimes it's more than a word. It really, I'm not a mathematician, so I haven't quite figured it out. The numbers at the bottom are the actual vector embedding representations, which is how the model actually works. So you send in text, the model converts it to using some mathematical algorithm that I don't know or understand, um, and then it deals in numbers. Right. So if we start looking at, okay, maybe number of messages, since most of these models are their window sizes is based on number of tokens, number of messages probably doesn't make, or message windows may not make a whole lot of sense. Maybe we should do it by token. So we can do it by token as well. And all the token counts, most of the model providers provide as part of the response, the token usage. And so, for example, if I go, oops, right, and I run this one. So for GPT-4o, as an example, for January, the way that they charge, the way that these models make money is data you send in and data you send out. Kind of like Amazon, it's cheap to send data in, but it's super expensive to get data out, right? But unlike Amazon, you can keep your data in Amazon and never take it out. With models, you have to get it because that's the whole point, right? You have to get the data out. So they charge, at least last time I checked, $2.50 per million input tokens and $10 per output tokens. So you can start to see how this might be additive, right? I'm building a chat bot which has 100 different simultaneous users that are having these long running conversations where I'm maintaining memory and I'm sending all this data back and forth. The cost of that starts to add up, right?
Yep.
So in this case, this one call cost me, I don't even know how to say how many dollars or cents that is, but it's pennies, pennies on pennies on pennies. Right. So I loaded my OpenAI account with $5 in January 2024. In February of 2025, it finally ran out of the $5. And each time I do this 3 hour talk, I think I use like 18 cents or something like that for all these demos. But it adds up. I'm one user doing a couple of queries, right? It could start to add up.
Claude's tokenizer said that the sentence was about 16 token, or excuse me, 13 tokens. So yeah, you're right. It's all different.
Where did my mouse just disappeared? Yeah, so in this case, yeah, there were 41 input tokens, 6 output tokens for a total of 47, but the input and output are charged differently. The input tokens are 25% the cost of the output tokens.
Yep. Yeah. I like the AWS analogy. Welcome to the AI California.
Yeah. Yeah, I figured anybody who's done cloud data transfers can understand that one.
Totally.
Right. But like I said, with AWS, at least you can leave your data there. You don't have to get it out. Here, the whole point is to get it out.
Right.
Right. So everybody good with that? I'm going to start talking about the declarative approach and the kind of the higher level abstraction on top now. So the way this talk is structured, it's kind of like building blocks and building pieces on top of it. And eventually we'll get to a point where we can kind of skip around into, if we have time tonight, because there's RAG, there's guardrailing, there's testing, there's scoring, there's lots of different interesting topics. But I think unless you understand like the basics of it, you kind of have to go in order here. So if we talk about these higher level abstractions, we can start to talk about, because I mean, this is okay. And this is what you see with like Spring AI is you get a chat client builder and you give it a model and then you call Exchange and you give it a query and everything is driven through API calls, right? Which you can do. You can do in Quarkus, which is what I'm doing here. I'm just injecting the the model. You might see there's actually a difference on the slide. Um, here's a here for the model. Yeah, you see here, I'm calling it chat model, but in here it's chat language models because LangChain4j 1.0 is coming out imminently. So they're making a crap ton of breaking changes in the betas in the pre 1.0. So this is beta 2. Beta 3 renames everything, and I just haven't gotten to the upgrade yet because it renames everything. So yeah, so if we look
Quick,
at
quick question from audience. Was curious how much of the session information actually goes back to the like in well, I guess he was asking to the open source library.
what do you mean session information?
Um, Happy, can you clarify? I'm not 100% sure what you're thinking of. You say session either, to be honest.
Yeah, actually, I was just curious, like how much of this, so you have these system and user objects, right? So just wondering how much of that is communicated back to the open source library,
So
or
they're
is
just
all of it just going back and forth?
So it's just data. They're basically like they're not Java records, but think of them as just data holders. They're like read-only objects that get passed around, and they represent the interactions with the LLM. When you start to get into auditing, they publish events that you can capture and you can do something with it, but there's nothing other than maybe if you turn logging on where it might log things out. That being said, if it logs out, it'll log headers, but it will mask like API keys and whatnot, so it won't, strictly log. But if there's sensitive information in like the system message and you have logging turned on, that will probably show up in your logs. It'll probably show up in your network logs too, anyway.
Got it. Yeah, I was just more concerned about the security aspect. So like yeah, if there is some sensitive information, so I assume it would travel all the way to the open source library and I guess parsed or whatever.
It's no different than any other open source framework like Spring or Quarkus. Like you could say, what I call REST template dot get for object, what's it doing with the data that I put in there? I'd have the same question for that, right?
Yeah,
Yeah, fair enough.
any remote web service you call.
Yeah. It's
Yeah.
just a placeholder object. It's a data object, essentially a value object. Yeah, so there was a question which version of LangChain. So 1.0 is supposed to come out early May, I believe. It's on 1.0 beta 3 right now. And I know they're trying to make like because it was started and it moved like really fast, and there's a lot of different vendors that are in there. Like Red Hat is in there, Microsoft is in there, Google's in there. There's a lot of different vendors. So they're trying to simplify the API and so that when 1.0 comes out, it's going to be backwards compatible for a long time without breaking changes. So they're trying to make all those like the nitpicky things like it should be named chat model and not chat language model, or the method should be called chat and not exchange. It's kind of stupid things like that that should have happened before. They're trying to make all those breaking changes. So I'd say with all the 1.0 betas that come out, each beta has a ton of breaking changes compared to the last beta. So if you start playing with it and you get on a beta, I might say stay on that beta until 1.0. But that being said, you might miss something too. They're trying not to add any major functionality in at this point because I'll talk about guardrails in a second, but there's a huge PR that I did that's been sitting waiting to be merged. And I think they're going to wait until after 1.0 to merge it just because it's a lot of new APIs and a lot of new integrations. So they don't want, and it'll be experimental. So they want to keep it out of the 1.0 API for now. There was
I
another question. I didn't see what it said.
think it was more of a comment.
Yeah, I mean, this whole AI space to me, like 2 weeks is an eternity. I mean, you saw like MCP came out and now Google has this A2A thing, and now people are doing agentic. Like you just like watch Twitter or Blue Sky or whatever. Every 2 weeks, it's like the pace of innovation is incredible. So like I would say like 2 weeks of any framework in this space is an eternity, which sucks for enterprise customers because getting a company to actually support any of this is gonna be hard, if not impossible, in the near term, right? So you think about like Spring AI or any of these things, nobody's going to support any of these things for a long time. Or I shouldn't say a long time, but for some time. because they're moving so fast,
Yep.
right? So here I take the same thing, I take that chat language model, and in LangChain4j, I can use this, they call it an AI service abstraction. I can create an AI service abstraction of this assistant, and this assistant is just an interface with whatever methods I want. If you don't do anything else and you just have one string parameter, that becomes the user message. And whatever the return type is, if it's a case of string, that's your input and output of basically calling the chat method. The power here starts to come when you start to add on to some of this stuff. I went back a few slides to show that, right?
Okay.
So when I start to show some of the stuff, and I'm going to stay away from slides, I'm going to try and stay in the code here because I think it means more. So when I come into this next thing, I know I didn't run that previous one. But now I have this assistant. Now I can define a system message. I could have multiple operations that pertain to this model, and they could have different parameters or different user messages or different templates, and now they belong to the model. And so I can set the system message at the operation level, or I could set it at the model level, meaning, up here at the interface, I could say at system message, right? I could put a system message at the top and then override it for one particular operation. So I can start to do kind of cooler and more higher level things with this. So in this case, if I don't define a user message and I still only have one string parameter, that is the user message. I could throw at user message here, but I don't have to, right? Because it'll just assume if there's only one parameter and it's a string, it's the user message, right? Do, 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 do. Oops, I went backwards. Sorry. The next thing that kind of starts to get interesting, well, if I can do this declaratively, chances are, like if I'm a user, like I'll go back to my American Airlines example, I want to change a flight. When I open up that chatbot, it probably already has some context of who I am, right? Maybe I'm in a reservation already, so it already has the context of my reservation. That means that the LLM can probably know specific information about me, which means my user message probably needs to be templatized, right? Because I don't want to have to, if I am supporting a multi-user system, I don't want to have to define these messages going back and forth statically, right? I probably want to be able to do variable substitution in them. So like in this case, your Shakespeare, all your responses must be an iambic pentameter, write a poem about some topic. In this case, LangChain4j uses mustache or a variant of mustache, the templating language. So now I can start to add parameters and I can define those parameters in my method signature. LangChain4j has this at V. I think somebody just did it one night when they had too much to drink. You shouldn't let developers name stuff, and this is how it ended up. Not very descriptive, but that's what it is. So this is how you associate which variable goes to which parameter in the thing, right? So now I can start to pass, and I can even pass complex objects and use like dot notation to navigate. So I could create an object which encapsulated both of these parameters, and I could say, obj dot, and I could start to now navigate my template and define objects that represent my data. Kind of neat, right? So now it even starts to get more interesting. So now we talked about, well, strings are great, but we're used to Java and we're used to structured text and structured things, right? So now I can create my interface and I can say, okay, here's my user message, my system message, which has a template, but instead of a string, return an object. And oh, by the way, this object is a Java record that is combined with two other objects. One of them is an enum and one of them is a string. What's actually going to happen here, if I go to, which project is this? This is 4, right? And if I run this, I don't have the logging turned on. Hang on, let me turn the logging on. Say Quarkus LangChain4j.
You still see it right now.
Yeah, I know. Well, you're seeing it because it's printed, because it's actually the code is actually printing it. I want to see the actual interaction with the LLM, right?
Mhm.
So I'm just going to add some properties here. Requests, right? So now if I rerun this, so now you can actually see the request. You see my system message is you are an AI that needs to triage user feedback. So here's my system message. You're an AI that needs to treat user feedback, analyze a given feedback, blah, 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 provide a summary of the feedback, and then here's the feedback. But you notice now it also says you must answer in the following JSON format, and it actually gives an example of the JSON format. LangChain4j is introspecting the return type, and if it's not a string, it's introspecting and it's providing additional information to the LLM as to how it should respond. And the response comes back in that format because LLMs are generally pretty good. Now, the local LLMs that you can run in your machine are generally not pretty good. And so if this is not JSON, like that can be marshaled into this object, it'll blow up, right? Boom. And you'll just get a 500 error, don't know what to do, right? So I'll talk about how to guard against that in a later section, but that's a very real possibility. That happens a lot, right? Or you get, like I said, this is JSON. Here is your JSON, tick, 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 and then in Markdown, you have the JSON. That is not JSON, right? All right, so structured output, memory. So yeah, so with this, you can also add memory to this. So the way upstream does this, and so this, when I get into Quarkus in a second, I can start to show what Quarkus does to make this even easier. But straight upstream LangChain4j, if you want to add memory, you have to have some way to manage the memory. But when you build the AI service, you also you give it a reference to the memory. So now your assistant in your interface doesn't necessarily need to know or care about those other operational concerns about how you're managing memory or how you're doing any of that. It's part of the underpinnings that you don't really necessarily need to worry about. I think in Spring AI they call these like advisors. You have to like build all these advisor interfaces and do all these advisor crap.
Yeah. Yeah.
Here it's a whole, and you'll see even in Quarkus now, Quarkus eliminates all of this too. So you don't even need to do this. It's just all it's like a single annotation on the interface and it's just done for you automatically. So yeah, so any questions about that? And I'm going to talk specifically about what Quarkus does and what Quarkus. So Peter, I'm not really watching the clock, so you tell me when you want me to stop.
Right. No problem. I mean, technically we have till 7. We can, I mean, to the extent that Philip is wants to go over, we can to a degree. Everyone still seems pretty engaged, and maybe this is a good point to do a checkpoint. Why don't we maybe pause for a moment and ask for some feedback on like where do you want to spend a few more minutes, and maybe we try to wrap it up in like the next 20-30 minutes.
Yeah, so if I go back to like my agenda here, like these like conceptual stuff, this is kind of like the last piece before we get it. So like once we get to RAG and function calling, guardrails, models, MCP, agentic, we can completely skip around based on what people are interested in.
Perfect.
But we kind of got to get through this last section before we get there.
And finish out your set piece for sure. Sorry. Yep, go for it.
Yeah, all right. So where am I going here? Memory. I'm trying to find the slide. All right. So now let's look at what Quarkus does on top of this. And I can't say what the Spring Boot starter does if it does any of this stuff on top of it for LangChain because like I said, I'm not involved in it. But what we on the Quarkus team, and so I'm a contributor to Quarkus. I'm one of the core committers on LangChain4j upstream as well as on the Quarkus extension. So I'm involved like from the beginning all the way up. What we generally do in Quarkus, because LangChain4j moves very fast, Quarkus itself moves very fast. We'll generally build in like lots of these extra capabilities when I talk about like guardrails and auditing and all these things. We'll generally build them in Quarkus first, and we'll kind of figure out how we want to use them in the declarative approach. And because we can get customer feedback really fast because we have a lot of people that are using it. And then once we kind of stabilize how it works in Quarkus, we'll then move it and commit it upstream in LangChain4j. And that's kind of the pattern that we've been following. We will build it. So some of the stuff that I'm going to talk about is only available in Quarkus. Some of it is available in Quarkus, has been implemented in LangChain4j, but hasn't been merged yet. But that's typically the process that we follow because a lot of us work in all three projects. So we kind of span all the different projects.
Makes sense.
So if you think about like I kind of talked about this, your typical CRUD or database application or a microservice that talks to other microservices, those things that you talk to aren't really different than a model. They're just integration points, right? That you generally would treat the same. The only difference is if I ask the same thing to the same database with the same data, I should be getting the same answer. Same with like another microservice. It should be, as long as it's an idempotent operation, I should get the same answer. But the models, I don't. Models, I could potentially get errors. I ask for JSON, I don't get JSON. I ask for XML, I don't get XML. There's lots of things that can go wrong. And so that's where you need some of this extra stuff that I talked about. And a lot of this stuff that's here now is only available in Quarkus. So like the observability, the auditing. So the observability part of it, the open telemetry integration, the distributed tracing, Prometheus, that's only Quarkus that's doing that. I'll show like a simple way to do RAG, that's Quarkus. The agentic, there's an agentic and MCP framework and LangChain4j. The Quarkus version of that is much more evolved than that. Memory management, managing context and different scopes of context is done in Quarkus. So if you think about like these interfaces that you build, these assistants that we've been building, and you think about scopes, well, these are, in Spring terminology, singletons, or in CDI terminology, application scoped, right? One instance per application. If it's a REST application, you probably either want it session scoped or request scoped, right? If it's a WebSockets are interesting because every WebSocket connection has its own unique WebSocket session, and that WebSocket session can hold data for the particular communication back and forth with that particular client, right? And when the client disconnects, the session gets closed. So if you're doing a chatbot type thing, you probably want this assistant bound to a WebSocket, right? So that way you're not leaking one user's chats with other users' chats. So LangChain4j itself isn't going to give you anything to do that. Like you have to manage that yourself. Quarkus will add that for you. So if you want an assistant that only lives for one request and then is gone, and if you give the same request again, it's a different instance, you can just mark it request scoped, and that's a standard CDI, context dependency injection annotation. If you want it application scoped, which is the same as like Spring Singleton, one instance per application, or if you want it session scoped, you just tag it with session scoped. It's also cool if you're doing WebSockets and you have the WebSocket dependency on your class path and you mark it session scope, Quarkus will automatically bind that to every WebSocket session that opens. And when that session closes, it'll close the conversation out automatically. If you wanted to store the chat history in something like Redis, it'll automatically do that for you if you have Redis on your class path and you basically enable the flag in the properties file and tell it where Redis is. It'll automatically offload the conversation memory to Redis for you. So it's going to give you a lot of the stuff that the core framework is not. Because the core framework is intended to be building blocks because it's completely agnostic to any potential implementation. Right? And so, like I said, you can start to build your own ways to store memory because LangChain4j, excuse me, will provide you these building blocks. So if you want to implement your own custom way of storing and managing memory, you can do that. The way you wire it in is completely different because in Quarkus, like kind of like Spring, you would just have a bean constructor or a bean producer of a certain type of interface, and it would just become a bean in the context. And if Quarkus finds a bean of that type in the context, it just wires it in for you. The big difference between the way Quarkus does it and the way Spring does it is that in Quarkus, this is all happens at build time. All these implementations get built at build time. Go back to the structured output, the introspection of the return type class and appending that to the system message. In straight up LangChain4j, that's done at runtime. In Quarkus, that's done at build time. So like Jackson, for example, the object mapper is compiled and built dynamically and statically at build time so that at runtime there's no reflection happening whatsoever. So all the core principles that Quarkus adheres to with build time adaptation and memory efficiency and whatnot comes into play here as well. So that's kind of something else. Being able to do native image and Graal VM native image and all that stuff is like a side effect of all of this because it follows the same design pattern.
Nice.
Um, Similar with like parameters and structured output. The only difference is, and I'll kind of illustrate this if I go to, where's Quarkus here? Here's it, chat models, AI services, Quarkus AI services. I went to the third one already. Sorry, it's like tiny on my screen trying to find it, the right one here. Oh, wrong one, 4. Oops, Quarkus AI services, 4. Dun, 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 dun. Right, so I have an assistant here. And I have, you see the user message in Quarkus now, instead of double braces is only single braces because Quarkus has its own templating language built into it. So rather than a mustache variant, it's called cute. And the reason Quarkus has its own templating language is because it's build time compiled. So if I have like this question here, if I were to change this, that would be a compile failure. It would fail at compile because it can't bind the parameter to the template. The template is compiled at build time rather than, oh, at runtime it doesn't match and it just doesn't work, right? And good luck trying to figure out why. Yes, I think I can even show that. Where is it here?
Null pointer exception.
Yeah, no, it'll actually be something that makes sense.
Okay. All right.
It'll be pretty specific.
That's cool.
At least it should be.
Better than better than null pointer.
Yeah. If I did something right, it should be. Oh, I don't think I have I have to set a flag or something. It should be. But you also notice that there's no like at v annotation anymore here. No, it's not available as a separate library. It's part of Quarkus. It's the part of the Quarkus goodness because it's very tied to the build process that Quarkus follows. Could do a whole nother talk another time about how all that works, but a different topic for a different day. So you can see like I can just start to reference it and I don't need any annotations because Quarkus is introspecting and
9926.
indexing. I'm sorry?
Again?
Yeah, so Quarkus is indexing all the methods and whatnot at build time. So it is actually doing this substitution at build time. So you don't need to annotate anything or give it any names to tell it which parameter. It's just using the parameter names and the method to do the binding. And all that binding happens at build time. All right.
Do we have a question, or was it just an accidental mute? Unmute. Okay. Go
Yeah,
ahead.
this is a selling point for Quarkus right there. String templates like that in Java for real? Oh.
Yeah. Yeah. So like you could even get why you would want to do this. I don't know. If you were doing this, this might be something in a code review. I pull up and say why not just create a template and abstract it? But it's the slide is here to show you can do pretty complicated templating with this. You can do looping and if then else and all kinds of crazy stuff. So like in this case, you're actually as the system message, you're replaying the chat history as part of the system message, right? Why you would want to do it, I don't know, but it's there, right?
Okay.
So we talk a little bit about observability, right? Integration with observability rather than on slide. Oops, I'm just going to show you. This is like the coolest thing ever. So you're familiar with like the LGTM stack, right? Loki, Grafana, Tempo, Prometheus, that stack for observability. So I'm going to come in here and you notice I just have my assistant and I have a REST endpoint, right? And I've got some properties. I'm just basically telling it to scrape the logs with OpenTelemetry. And I have, some dependencies on my database or on my class path. So if I come into here and I go, and I do run Quarkus in its dev mode, this is like killer. Like people like drool over this. Oh, So it's downloading. You notice it's downloading. So this is kind of another feature of Quarkus is what we call it dev services. So any kind of thing that you have, whether it's a database, message broker, Kafka, OpenID Connect, whatever the thing is, if you have a dependency on it and you don't configure it, Quarkus will download a container image and start and bind the container image for you. Spring Boot has something similar, like the Spring Boot test containers, but you actually have to write the test containers code to do that. In Quarkus, you don't have to write any of that. It's code. There's no test containers dependencies on my class path at all. Quarkus just
Really?
does it for me. So you can see my app is up, Grafana's up, Open Telemetry Collector's up, Loki's up, Prometheus is up, Tempo is up.
That's
Um,
super cool. I did not know that. That is very, very, very cool. No explicit like test containers calls. Wow.
nope, nope. So you see my project here. I mean, there's two
Yeah, yeah, yeah.
classes.
No, you're right. Yeah, yeah. There's
There's
nothing.
source main Java and then source test Java. There's just a rest assured test. There's no test containers. If I look at the POM test,
Cool.
there's no test containers code in here whatsoever.
That is really cool.
So now if I go back to my dev mode, right? The dev mode thing that I showed you before, this little thing. So if I go to, let's see here. So I need to make a request first. Do I have Swagger UI? I don't think I have Swagger UI. Yeah, Swagger UI. So I'm gonna go into Swagger UI. And so this is like doing something with NBA players. So I'm gonna say I'm in Boston, so I'm gonna say Larry Bird, right? Gotta say Larry Bird.
Sure.
Right. So it's gonna make a request. You've got the logs right here. And you notice every container. So if I go to this dev services tab, I've got the observability dev service up. The dev service observability, all the container logs are automatically forwarded to this dev UI as well. So if I want to debug what's going on in one of those containers, if it was Postgres or anything, the logs are right here. I've got my testing log if I wanted to run all my tests. I've got the observability log. I've got my application log. I can see my post. So here's my post. Here's my response, right? I can come back to my dev UI and I can say, oh, here's Grafana. I can go into my Grafana dashboard. I can say explore Tempo, do a trace search. Here's my service name, and I want the span of post NBA, which is where I did that HTTP post, run my query. I've got one trace. If I hate the Grafana UI is awful. I hate the Grafana UI. Move this over. And now I've got a complete trace. So I can come in here. I can click the button. All the logs across the entire trace have already been correlated for me. And I can deep dive in. I can get it as JSON if I want. I can download it. I can resort it. I can start by going into Loki and finding a log statement and clicking on the log and going into the trace that way. I mean, everything is already timestamped and correlated with each other. Here I can see, here's my request, my response. If I come back to Loki or to Tempo here, this is the actual call to ChatGPT. Here's my span. I don't know if you can still see it, but here's all the span attributes. It was GPT 4.0. Here's how much this call actually cost me.
Nice.
And then I could go into Prometheus, and I don't know what metrics are there. I'm not a Prometheus expert, but I could start building Prometheus, and all the metrics of the whole app is there, so I could start monitoring and whatnot. And that's just out of the box. I haven't done anything.
Very cool.
Yeah, I like that one. That one always blows people away.
Yeah. Thank you. I did not know that. Very cool.
But I don't know what happened. It went out of. All right, so that's Grafana. And I think there's even some, I haven't played with it, but I think there are some dashboards. Yeah. I go to Grafana dashboards. Oops, I stopped the app. That's probably why it doesn't work. I don't want to start it. I don't want to wait for Grafana to start again.
All good.
Anyway, all right. Yeah, so these are just screenshots, but looking at the real thing is better. So I can also do, so I talked about auditing, and I feel like auditing is super, like, I think what's missing in the industry now, like if I were to ask the question, if you change your prompt, is your prompt, even though it's a string, should you store your prompts in a database so that you can change them easily? I would say absolutely not, because if you change your prompt and you don't retest, that's like your code. You could completely alter. It's like storing a SQL query in your database, right? Querying a database to get a query that I want to run. If you change the model and don't change the application, you're could have a profound effect on your application. So what I find is missing is a way for people who are doing this to be collecting, if you think of the log as the log goes back and forth, what questions are people asking? What models are they asking it to? What are the answers? And how relevant are the answers, right? And you can only know that if you track it. And if you change the model, you can only evaluate, did I get better or worse, if you know how good you were doing in the first place and what was happening in the first place. So being able to do things like and this is again something only in Quarkus right now, is CDI exposes kind of like if you're familiar with Spring, and Spring has like the application event publisher, and you can tag a method with at event listener and listen for a particular event. CDI has this kind of similar concept, so it uses this observer pattern. So you can have there's a ton of these different events that you can observe, and the observer they can be in the same class, they can be in different classes. I just put it all in one class just to make it one bean. But you could observe these events multiple places in the same application. Anytime a message gets created, anytime an LLM interaction completes, anytime an LLM fails, anytime the response comes back, anytime a tool gets executed, when the tool responds, all these different events that happen are published as events that you can listen to and do something with. So you could store them in a database or put them to Kafka or doing something else with them. Do whatever you want, whatever makes sense for you.
Any security concerns there? Like, can
Well,
you just disable this if you want to?
you wouldn't listen for the events. The
Mhm.
applications will always publish them. It's just what you do with them because the framework and the itself isn't doing anything with them. It's just publishing them when they happen. It's up to you to define what if you want it, if you care about them to register to listen and then do something. But again, this is right now, this is only in Quarkus, but it's one of those things that will be available upstream. It probably won't look like obviously CDI event handlers because LangChain4j is agnostic to things. It'll probably end up as like an interface with methods. So, but I don't know exactly. It's on me to build it, so I haven't quite thought about it yet. Because I built the Quarkus version of it, but I haven't integrated it yet. Fault tolerance, so like being able to like when things go wrong, like handle that because things are going to go wrong, not when things go wrong. Or I guess that it's not if things go wrong, it's when things go wrong. What do you do about it? Right? So micro profile, kind of like the Netflix stack for Java, for non-Spring applications, defines how to do retries, how to do timeouts, how to do rate limiting, how to do fallbacks, how to do circuit breaking. All that fun stuff is part of the micro profile fault tolerance spec. So in Quarkus, you can just take those annotations and just put them on the interface methods and they work, right?
Nice.
So in this case, this ask method, if it fails, it'll retry twice. It'll time out. If the LM doesn't respond in a minute, it'll time out and it has a rate limit of 50 requests per minute. And if there are any errors, it'll come back to a fallback. I could also get cute and define like there are different exception types, the different exception classes that could happen. Like in the case that the tool call failed versus the LLM didn't marshal correctly to JSON, I could catch specific exceptions and it would only fall back on those particular cases. Right. So whatever you can do in microprofile fault tolerance, you can do here. And this again, this is Quarkus only because LangChain4j upstream it's not geared to any one particular framework. So if you could take LangChain4j with Spring and use like resilience for J if you wanted to and do similar things, but you'd have to build the capabilities and the interceptors and all that stuff yourself. In Quarkus, we're doing it for you. All right, so that's like the Quarkus specific stuff. So that's kind of like we're at a break-even point. We can either stop. I'm happy to keep going if people want to keep going, or I'm happy to skip around. It's whatever you want to do at this point.
Cool. Let me just check in with how people feel, and also just your time because I know we were normally booked till 7, so I don't want to abuse the privilege. But
Yeah, so somebody asked, well, can this be used as a library on a Spring? Yeah, so LangChain4j itself, the upstream can absolutely be used as in a Spring application. The the auditing part, the resilience part is not part of that. That's in Quarkus and Quarkus only.
Part two of this.
Yes. Yeah. Tomorrow. The office is starting to empty out a little bit. So just out of respect for the folks that are here, I think we do need to kind of wrap it up.
Okay.
But unfortunately, let me go back to the top of the chat and plug your information again for tomorrow's session. And then I'd be more than happy to set up a part two for
Yeah.
this. I'd be happy to. Seems like folks would be interested. If you can hear me online right now, and you're on the Zoom, and you would like me to schedule a part two with Eric, please just hit thumbs up or send an emoji or do something, and say something in the chat, whatever. Let me know that you're
Don't just
interested.
leave.
Lada, I see you. Yep. Okay, cool. So we got a couple of yeses on that. So yeah, Eric, I will arrange that with you at some point at your convenience. I know that you're staying up past your bedtime for us, so thank you for that.
Yep. So tomorrow at the Central Iowa Jug, I'm basically starting right where I left off right now.
There we go. So that's then that's
It'll just be
perfect.
early. It'll be early for you West Coast folks. It'll be 3:30 in the afternoon.
And the link is I just put the link again once again to what Eric was just talking about. So you can go fetch a part two tomorrow. If not, we could arrange a separate one at a convenient time. Maybe just hit me up on LinkedIn or Meetup platform and let me know if you weren't able to make it. And if there's enough interest, we'll do a part two. We did have a couple questions. Let's see. Did you get to those while Philip and I were talking, or no, not yet?
Let me say, out of curiosity, what is the new way of calling REST servers instead of so in Spring World, that's like there's this new like web client, right? That's supposed to be reactive or non-reactive, but REST template or whatnot. In Quarkus, we use the um, the micro-profile REST client, which looks like Feign does, and I find it much easier to use. Let me see if I have an example somewhere. Um, I can show you what it looks like. Yeah, so in Quarkus world, this you could do it programmatically if you want. I mean, the API is there and you could use a builder to build it yourself. But this is how most of the world does it because you can start to create a key and then drive it through properties. And then you could even build resiliency and whatnot through properties. And you just build it like this. So this exposes a get to the path and you define the URL as part of your property configuration. So environment variables or whatever. And then you define basically you define it like you're defining a server, except it applies to the client, just very similar to how Feign works, like almost similar conceptually. It's the exact same thing conceptually, just using Jakarta RS. So this is not anything specific to Quarkus. So Quarkus borrows and reuses most of the specs that came from Jakarta. So Jakarta REST and JPA and all those things. It works with all of those. So this is just Jakarta RS.
Backing up a teeny bit, I think the only outstanding question was from Hari, was just asking, do you have a preference on LLM hosting, like Llama versus VLLM versus Llama.cpp versus Docker?
So for my machine, I use a couple of different things. So I have a Llama here, right here. The kind of the cool thing with a Llama and Quarkus, if you're using Quarkus with a Llama, Quarkus, if you're not running a Llama and you want to use a Llama, the dev service will automatically spin up the Llama container and download the model to it. If you have the Llama client in your machine, the Quarkus dev service will see that you have the model machine and it will share the models between the container and that. Um, so that's kind of cool. I use LM Studio a lot too locally, and I use Podman Desktop, Podman AI Studio. If you're not familiar with that, I can do that quickly. But we're not allowed to install Docker on our machines. The Docker because you have to pay for it.
Right.
Not because we're Red Hat, but because and we build Podman. It's because of money.
Yeah.
So where is it here? My icons are so damn small. Yeah, so Podman Desktop. If I come in here, Podman Desktop is pretty neat. I don't know if you can. My resolution is tiny, so I can go into like this little AI studio extension here, which has all these different models, and I can, find a model catalog, and I can pull a model from Hugging Face, and I can run it, and it exposes an OpenAI compliant API around it. And it can run it. It takes advantage of your GPUs. If you're using GPUs, it'll use that too.
Nice.
So, but mostly I use Llama.
I'm curious to hear your MCP segment tomorrow, so I'll try to dial in or zoom in. That'll be fun.
Yep.
I think there was one last second part of Hardy's question was, can this be used as a library on a Spring app? And I'm not sure, Hardy, maybe if you can clarify that. I know we missed the question. So what is this? When you said can this be used as a library on a Spring application? Can you?
I believe Eric answered that. I was saying instead of using an OpenAI library, we could use the interface, the way which Fein does it for us, right? This interface seems really intuitive. I was planning to use it on a Spring application, and he answered the question essentially. Sorry.
So you mean like the AI service abstraction? Yeah. So the AI service abstraction in LangChain4j you could use in Spring and Spring Boot. So you would so the code that you do, where is it here? Hang on, let me find my example, my plain LangChain4j example. So in plain LangChain4j, if I did this and I built this interface, and then I have like this code which does AI services.create. If I were in Spring, I would have like an at configuration class, and I would have a method like triage, and it's not going to compile because I don't have the Spring libraries, blah. And you could do like at bean, and then you could just copy this line and return this. And now that would expose that interface as a bean.
Are you sharing something? I think I might have missed it.
I think I'm sharing something. Am I
Yeah,
not?
you're sharing the screen. Good.
You don't see the screen share? Do people see the screen share?
Yeah. We do.
Yeah. So you could do this in Spring Boot, and that would expose this interface as a bean. But the configuration of it, like, it wouldn't be property driven. You'd have to configure everything. You'd have to like take in the chat language model. You'd still have to construct the chat language model yourself and all that. And that's what Quarkus is doing for you. Yeah. And so the last question was,
Yeah, but like just to add on to it, Spring Boot, like Spring AI would have an equivalent which would be property driven, number one. And number two, it's in a way it would be trivial, like it would be trivial to make construction of the bean itself property driven.
yeah, but Spring AI does not give you this.
Yeah, true. But again, like even for this itself, this bean itself, it would be trivial even with Spring to make the model construction, the bean construction property driven. It should be straightforward to do.
Yeah, it would be straightforward to do bean construction and bind it to configure like an at configuration properties.
Yes.
You could very easily do that. This part of it is what Spring doesn't have, and all the intercepting and what's going on behind the scenes, integrating the observability into this is what Spring AI is not doing right now, and what they don't have. The other part of this is like all of this, it happens at build time in Quarkus. So like Spring AI suffers from all the same problems that Spring Boot has. And so
You're not
I
gonna
don't
get
want to get into a Spring versus Quarkus war, but it has all those same problems.
Hey.
So Ram had asked, is MCP already in Quarkus? So there's a Quarkus LangChain4j MCP client and server. So I could build and I have that example too. It's in one of the things I was going to show. So I could build a server and expose it through MCP, and I can use the client and build MCP clients.
just be careful doing that because there's like really no security baked into MCP whatsoever. So think twice about putting it into production. But it's coming with the spec, like the collaboration around it. I think is happening quickly, and people are realizing that it's early days, and no one's expecting it to be the all singing, all dancing thing. But think about it a little bit before you go into production.
Yeah, that's your project manager hat talking.
It is. It is.
Yeah, so you see this slide, this is the last slide in my MCP section here.
Nice. I love it. Yep. Yeah, if we're not careful, we're going to end up in like SOAP, WS Splat, spec hell.
It's funny you should say SOAP because I have a slide that talks about that.
Nice. Yeah.
It's like,
Yeah,
hey, I've got this random code. Can you just eval it on your server, please? Thank you very much, and not have a problem with that.
exactly. Exactly. Yeah, it'll be fine. Cool. And yeah, I think Hari, not to get on the Spring versus Quarkus train, but I think what Eric was saying was very powerful in the sense that it's all build time, and graal native images really are a nice thing. And that's going to be it's going to take Spring a while because as a former Spring team employee, I know very well how much reflection they used in the code base. And it's a lot. So, and that's one thing that Quarkus has done really well as the kind of reactive stuff under the covers. So there's some great reasons.
Yeah, I think you'll find too that like I'm trying to say, how to say this delicately. The way Quarkus works, so like you could take the same application in any one instance of it. The Quarkus version is gonna time to first request is going to be about half. The memory footprint is going to be about half, and it's going to serve about 4 times the throughput that the same Spring application is going to serve in a generalized use case. I mean, it will vary, your mileage will vary, but it'll always be better. I would also say the Graal VM and native image, a lot of the Spring folks look at that and they're like, oh, this is our savior. But I mean, like everything, there's a trade-off. You pay the penalty for that at build time. What we typically find with Quarkus is you don't even like the use cases for native image are probably in the minority, like maybe 15%. Most of your Java apps belong on the JVM, and therefore Quarkus is optimized for the JVM. Sure, you can do native image if you want, but it's not a requirement. And in some cases, we've even benchmarked Quarkus on the JVM is similar performance and size than Spring and native. So we always recommend do JVM first, forget about native image unless you really need it, which is
A
not
lot
the
of
same tune that they sang.
true. Yeah. A lot of go for it. Why don't you be our last question and then we'll wrap it up.
Well, sounds great, thank you. Eric, can you go a little bit into agentic stuff? So, like, what kind of agentic stuff do you support, either in LangChain4j or in the Quarkus version? And what I'm really curious about, like, I haven't done agentic programming yet, like this. So really interesting how to orchestrate agents. Like once you build an agent, where you host it, and all that stuff, all these patterns kind of, because I start to think this kind of becomes a microservices 2.0 a little bit. Maybe I don't know much about it.
Yeah, I guess I'll give you a general answer, yes, because I think it applies to all your things. So in the case of like, so here's an example. So I build two applications. So the agent is conceptual. Think of it as like a microservice. I'm building something that knows how to interact with something where it doesn't have to share the implementation details with something else. So in this case, I have I have a client which talks to where is it here? Just the there's a public API for getting weather. Where is it? Weather.gov, right?
Yeah.
So I built a client around that, right? And then I expose it because not only do I need to talk to the weather client, I also need to be able to take in like, hey, what's the weather for this city in this state? So I need something that knows how to find out what state a city's in, and then convert that to latitude and longitude because that's what the weather service takes, right, to get a forecast. So I can define, and I didn't get into tools. So when you get into tools, you define tools just by creating beans and adding a tool annotation. Well, this is just a tool annotation on a bean. But because it uses the Quarkus MCP server, it automatically registers itself into the MCP protocol. So then when I build a client, in this case, it's using the MCP HTTP, not standard IO. So when I call this and I have a client that uses the MCP client, I can just define different tools that are available, MCP tools, tell it what type and where they are, now I don't even have to bind it to my app because of this declarative interface. It knows based on the configuration, I'm an MCP client and this is my MCP service. It will automatically register these as tools that are now available to my LLM. So when my LLM response, again, I didn't get into tools, so you didn't see this, but when you send the request to an LLM, if you're exposing tools, you have to describe the tools to the LLM. And that's part of the body of the payload that goes over. You would see when you called this thing, all these tools for the MCP client or for the MCP server going over and being available. If the LLM responded to call the tool, the app would call the tool. So that tool provider is automatically registered by Quarkus for you. And again, I haven't written a line of code to do it. All I did was configure it and add a dependency.
And if you start building it, and so you have another agent that uses this agent, right?
Yeah,
That
so
kind
I
of
could
becomes
have multiple
microservice-y.
agents. So this app could use multiple agents, like in like this
So one of the
example
agents
here.
can be a tool for another, right? Something like
Yep,
that.
one agent can be a tool for another. One agent might have access to one tool, but not access to another tool. And so now I can start having multiple agents and having all these these other servers all over the place, or even multiple agents in the same application. And the building
Awesome.
blocks for all of this is in LangChain4j.
Mhm.
The building
Okay.
blocks, like how the interfaces and all that stuff is in upstream LangChain4j. It's just Quarkus has the implementation to just make it all work for you. In LangChain4j, you'd have to like build it and then assemble it and do all that stuff.
Eric, I'm excited to tune in tomorrow. I think you'll see me there. I have one thing in the afternoon, but I'm hoping I think I can make it. I just need to check my calendar. So, great. This is awesome whirlwind tour. And thank you very much. I think we're gonna have to close it out just because the Elastic folks need to go home. It's a little late.
You're getting
Here is
some inconspicuous stairs.
yeah, starting to get there, starting to get there. Thank you very much. Really wonderful. And I didn't realize that Quarkus had already like jumped on the MCP bandwagon. I can see the Tron memes, coming any minute now in your slides. I don't know if you remember the original Tron movie. What was it?
I never saw the original Tron movie. I think you're dating me.
Master Control Program. Go look it up. It's a good source of memes. Because there's a new Tron movie coming out anyway. So I think I'll help you up your meme game there if you want. Thank you seriously, and look forward to seeing you tomorrow. Really appreciate it.
Yeah, no problem.
Good stuff.
And I'll reach out. We can figure out a daytime to do this again.
Yeah, and just if you wouldn't mind, I know you had a couple of URLs. So at your leisure, just shoot me over an email with the URLs for the source repositories and stuff, and I'll make sure that gets into the YouTube video description. Okay.
Sure.
All right. Thank you, everyone online. Really appreciate you being here, and we will announce our meetup next month pretty soon. We just gotta get it booked. So looking forward to that, and who knows, it might be Eric's part 2. You never know. All right. Have a great night. Thank you for staying up late for us, Eric. Appreciate you.
Yeah, no problem.
All right. Be well.
Thank you.
Bye.
Bye. Thank you, Eric. Thank you. Let's see.
Thanks,
I
guys.
think if I just hit end, it'll stop recording. Yeah. Okay. All right.